couple of weeks ago, I got a call from a amateur radio friend that said a friend of ours was rebuilding a receiver and he needed some knobs. Asked me if I could make a drawing to 3D print some knobs for his receiver. He brought me 2 knobs and I measured them up, made a preliminary drawing on the CAD program, sent him the appropriate file for his filament 3D printer, and he did a test print. The test print didn't come out really well. As you see, the knob has a few features on it. Recess in the top with a aluminum trim ring, a set screw, shoulder at the bottom, recess at the back with a brass insert for attaching to the shaft. So the test print didn't come out well. The printer, the filament printer he was using, could not handle the, if I can keep this from rolling, find a pointer here, could not handle building up this. That got really messy. The recess got really messy. So I looked at it and said, well, we'll see how this stuff machines. So this is what I came up with. I did manage to machine the back shoulder and the recess. Got a horrible surface finish on the inside, but that's in the back. It'll be viewed like this. The center hole should not be there. The knurling was too light, so I revised the drawing to increase the knurling, put in a set screw depression, take out one of the knurls for the white line, but made it without any recesses in the back. My goal is to cut the appropriate recesses. This is the print against the original knob. My goal is to work the recesses here, in here, make the brass bushing, and make the aluminum trim ring. So I don't know if it's going to work. This stuff is really soft. When I machined this, I put it in the 3-jaw, and it did put indentations. So I think I'm going to have to use a collet of some sort to hold this in the machine. But we're going to give it a try, see how it works. I thought this might be an interesting project. Let me know in the comments if you think this is interesting, or have any suggestions on how I might fix a problem like this in the future. Let's get to the machine shop and see what happens. First thing I had to do was make a collet. This is boring out the final few passes in the collet. Had it bored out to the outside diameter of the knob, and then cut a slot in the through the collet after parting it off. That's was clamped in the 3-jaw, and it held the knob fairly well. I've got the 3D printed knob in the collet. I've got the carriage stop set to the proper depth of cut for the shoulder. I found out working on spares that about 300 RPM seems to work pretty good. So we'll touch that off. Now we'll measure it, make sure looking for about 850 thousandths diameter, and that's a little less, so that'll work just fine. Now we need to drill it and set up for the boring. I'm going to drill this about a ½ inch deep. We'll come back at a later time and check out the final dimensions of this. Again, around 300. This is about 400 RPM. Get it much faster than that, and the plastic softens and doesn't cut. There's been a little bit of experimentation going on to get these speeds and feeds right. Okay, there's a ½ inch deep. Now we set up. Again, I've got the carriage stop set. These dimensions aren't real critical. This recess is to clear the nut on the front panel of the radio. I'll take another 10 thousandths off of that. And there we have the recess in the back. little deburring with an X-Acto knife. Finish that up later. The next step is boring that internal hole to the proper diameter. I decided to use a end mill in the chuck, and I had problems with using the end mill and even running it at slow speed. It would deform the metal, and the pressure on the tool would make a bump on the top. So what I decided to do is turn it by hand. This way it's not building up any heat, and feeding the end mill in, getting a good cut. I can feel when I hit the bottom of the hole and get the drill cone cleared out. It makes a pretty good receptacle, I guess you'd call it, for the bushing. Check it out, see that the bottom of the hole is square. It looks pretty good. It's going to need some deburring and cleaning up, but that pretty much takes care of making the knob. Now we have to make the bushing that takes the shaft. The shaft on the components on the radio are 1/4 inch diameter. So this is a 3/16 stock. Got it in the 3 jaw. Going to face it, drill it, ream it to a 1/4 inch, 1,000th oversize. Reaming out to a 1/4 inch oversize. So the shaft fits comfortably. That feels like the bottom of the hole. Now we'll part that off to the length of the required length of the bushing. And there we have the bushing. When I made the drawing, I put a detent for the set screw hole. Now I have a clearance drill for a number 832. Center that on the hole. I decided to drill the plastic first, then when I wouldn't go too deep in the bushing if I did it all at once. Again, I've got it set at slow speed, about 400 RPM. Just go through easily, drill the hole. And then that's all I have to do for that hole. Then I have to put the bushing in, come back to the mill, drill the hole for a 832 set screw, and then we complete the job. Now we have to put the bushing in the back of the knob. I think I mentioned before that I'm going to put the bushing in and then drill and tap it. So I'll put a drop of super glue in the hole. And then I've had trouble with the ridges breaking off of this, the top half of these knobs. Place the bushing in, and then tap it good to get it seated, and it should stay there. Then all we have to do is drill and tap the set screw hole and move on to the next step. Now we center there's a flat on the other side, 180 degrees from the hole, where the line is going to go. Now we center the hole with the bit we used to drill it, and change that out for an 832 tap. 832 tap drill is a number 32 drill. So we put that in. And drill through the brass bushing. And tap at 832 for the set screw. Got a piece of 1-inch aluminum in the round stock in the chuck. We're going to make the trim rings for the outside of the knobs. So face it off. The goal is to get all 4 trim rings out of this one setup. First thing we have to do is turn down the outside dimension to fit the inside dimension of the knob. The inside dimension of the knob measures roughly 850 thousandths. This piece of stock is 1 inch. So touch off. That measures 0.985. Probably should end, but I'm just going to go ahead and run it. .947. I'm going to take 10,000 deep cuts so as to not get too much tool pressure on it. .925. Okay, that is a good slip fit. I plan on gluing these in anyway, so I think that'll be just fine. I'll drill this out in preparation for getting the boring bar to get the inside diameter. Using a spotting drill. Get a good center hole in there. Drill this out in steps. I want to get a little over an inch in depth so I can get all four trim pieces. That's pretty close to 70 thousandths. So and all we have to do is deburr the ends and part it off. And there's 4. I'll get those all deburred and everything will be ready for assembly. Trim rings are all cut and ready to be installed. Similar process to what I did to put the bushing in. A little super glue in the knob, a couple of different places around the rim. Take the trim ring, set it in, tap it a couple times with a little hammer. Trim ring is seated. Then all we have to do is the small knobs. I'll do that off camera. Put the last set screw in. and the project is complete. There are 6 new knobs, 4 small ones, 2 large ones, and these are the originals. I think the project turned out fairly well. It is kind of difficult to machine that PLA plastic. Can be done, but I wouldn't really be looking forward to doing it again. I learned a lot, but I hope my friend Joe will be happy with these knobs and get on with his rebuilding of the 1953 radio. Thank you all for watching. If you've watched till the end, please like, subscribe. It'll probably be a while before I post again because I've got some shows upcoming, and let me know in the comments if you'd be interested in me videoing a little bit in some of the shows. I have a hard time videoing during the shows because I'm busy, but I can take some time out to video if I get some interest. Again, thanks for watching.